Okay, let's dive into something pretty fundamental, but maybe something most of us never really stop to think about. How we build really big, strong structures and, make sure they don't fail.
Right.
Think about bridges, skyscrapers, even those massive tanks holding liquids or gases. They're often welded together.
hmm
But how do we actually know those welds are strong enough that they're safe and, well, reliable?
That is the absolutely critical question, isn't it? A welded joint, it isn't just two bits of metal stuck together.
No.
It needs to perform under specific loads, maybe temperatures, pressures. It needs specific mechanical properties.
Okay.
And ensuring that, it takes a really structured, quite rigorous system.
And the source material we've been looking at, it's basically a deep dive into that exact system, right?
Exactly. It lays out the two main pillars that support quality and safety in any fabrication that involves welding.
Okay, two pillars, what are they?
They are the Welding Procedure Specification, usually called a WPS, and then Welder Qualification.
WPS and welder qualification.
Yeah, and they're totally interdependent. You absolutely need both. A proven method, the WPS, and a skilled person who's qualified to actually execute it.
Got it. So our mission here really is to cut through some of that technical jargon, unpack these terms, WPS, welder qualification. We want to understand, what are they? Why are they so critical, non-negotiable, really, for safety?
Yeah.
And how do they actually work together to kind of build reliability into the world around us? Think of this as like a shortcut to understanding that invisible foundation of quality.
That's a good way to put it. The fundamental challenge, like you said, is making sure these welded joints don't just hold, but that they have the right mechanical properties.
Right, like strength, toughness.
Exactly. Strength, toughness, ductility, whatever is needed for that specific job.
Yeah.
Because welding itself, it changes the material right around the weld.
Ah.
So you can't just assume the joint is as good as the original metal it's joining.
And that's where the WPS comes in. That's the control, the instructions.
Precisely. The WPS is a detailed, written document. It tells the welder exactly how to make a specific weld.
Everything.
Pretty much everything that matters. The type of welding process, the filler material to use, the joint design, voltage ranges, amperage ranges, travel speed, any temperature requirements.
Oh.
It's all laid out.
Wow. So it's like the recipe down to the finest detail.
It really is. And it serves two key purposes. One, it guides the welder on the shop floor.
Okay.
And two, it gives a clear standard for the welding inspector to check against.
Yep.
Is the welder actually following these specified conditions?
Right, checking the work against the plan. And the source made it clear, you can't just hand someone a WPS and say, okay, go weld that bridge column.
Oh, definitely not.
The welder has to prove they can actually follow those instructions and produce a good weld first.
Absolutely. A welder has to demonstrate their ability, show they can produce non-defective welds by following a procedure before they're ever allowed to work on the actual critical production joints.
Okay, that makes sense. Which leads us nicely into that first pillar in a bit more detail. The welding procedure specification itself. How does a WPS get, qualified? How do you know it's reliable?
Well, the industry standard demands qualified WPSs. That means the procedure isn't just written down, it's been tested, proven to consistently produce welds that have the required properties.
And how do you prove a procedure works? You can't just write it down and hope.
No. The main way is by performing a test weld. You actually do it.
Okay.
You take a sample piece of the material you're going to use in production, prepare it with the specific joint design from the WPS, and then you weld it, precisely following that proposed WPS.
So you make like a practice piece first
Correct.
to see if the recipe actually works, delivers the goods?
Exactly. And there are two main goals for this test weld. First, you need to confirm that the finished joint has the necessary mechanical properties.
Strength, bending.
Yeah. Is it strong enough? Can it bend without breaking? Does it meet what the standard or the engineering design requires?
Okay, goal 1, properties.
Goal 2, just as important, is proving that it's actually possible for a skilled welder under controlled conditions to produce a defect-free weld using this procedure.
Right, so the method itself has to be capable of producing a good result.
Correct. The underlying principle is, if it works perfectly in the controlled test environment, following these steps, then it should also work in the real world during production as long as those same steps are followed.
Okay, that logic holds. And the source walked through a typical sequence for this qualification.
It does, yeah. Like the one detailed in its table 6.1, it shows the flow.
So let's trace that. Who kicks it off?
Typically, it starts with the welding engineer. He or she writes up a preliminary WPS, often called a PWPS. This details how the test coupon, that sample piece, should be welded.
So that's the initial plan, the draft recipe.
Exactly. Then a welder takes that PWPS and makes the test piece, following it strictly.
Yeah, okay.
Now, a really crucial step happens here. A welding inspector needs to be present, watching, and recording the as-run conditions, meaning exactly what parameters were actually used during the welding, the precise amperage, the voltage, the travel speed, the temperatures recorded, because these are the conditions that actually produce that successful test weld.
Ah, so the as-run is the verified working recipe, not just the initial plan, which might have needed slight tweaks during the test.
Precisely. And sometimes, for extra credibility, you might have an independent examiner or a third-party witness involved during the test.
Okay. So the weld is made, conditions recorded. What next? Testing.
Rigorous testing. First up is usually non-destructive testing, NDT.
Things that don't break it.
Right. Methods that inspect the weld without damaging it. So visual inspection is always first. Then maybe magnetic particle or penetrant testing to find surface flaws. And often radiographic testing like X-rays or ultrasonic testing to look for internal problems. Depends on the standard.
Checking for hidden cracks or, I don't know, bubbles inside.
Exactly. Internal integrity. If it passes all the required NDT, then parts of the test piece are usually cut out for destructive testing DT.
Okay, now you break it.
Now, you break it purposefully. You pull samples apart in a tensile test to measure the actual strength. You bend samples in bend tests to check ductility and make sure everything fused properly. You might cut sections, polish them, and etch them. That's a macro test, to examine the weld's cross-section and the heat-affected zones around it.
Literally trying to find its limits by destroying it?
That's the idea. And the source also notes, depending on the specific material or the application, say, for very cold environments or corrosive service, the standard or the client might require additional tests. Things like hardness tests, impact tests for toughness, maybe even corrosion resistance tests.
Wow, okay. That generates a whole load of technical data.
It certainly does.
Right.
And all this data, the verified as-run welding conditions, the successful NDT results, the successful DT results, gets compiled by the welding engineer.
Into what?
Into the Welding Procedure Qualification Record, the WPQR.
WPQR. Okay.
This is the formal official document. It's the proof that the procedure works under those specific as-run conditions. And based on the rules in the relevant standard, it also defines the range of conditions that are now allowed for production welding using this specific qualification.
Got it. So the WPQR is the official stamp of approval. It says, this method works, here's the proof, and here are the boundaries for using it.
Perfectly put. And sometimes, yes, a third party might also sign off on the WPQR just to verify its accuracy and that the tests were done correctly.
Okay, so now you have this WPQR, this proof. How does that turn into the WTS that the welder actually uses on the shop floor? And what are the rules governing all this? Sounds like standards are key.
Absolutely. The WPQR is the foundation, the verified test result. Then major standards like EN, ISO 15614 in Europe, or ASME Section IX and AWS D1.1 or D1.2 in the US, they dictate how you use that WPQR.
They are the rule books.
They are. They define exactly how that test piece needed to be made and tested in the first place. They specify what information must be included on a final qualified WPS. And crucially, they define the range of production welding conditions that are covered by that single WPQR test.
Ah, the range. So they essentially say, okay, because you proved it works exactly like this in the test, you're allowed to use a slightly wider version of that recipe in production.
That's a great way to think about it. The standard defines that qualification range. It sets the acceptable upper and lower limits for various welding parameters, amperage, voltage, travel speed, material thickness, and so on that you can use in production, all based on those as-run conditions from your successful test weld.
Okay.
And that allowed range is what gets written onto the final qualified WPS that the welder uses.
Okay, so WPQR is the detailed test report. Qualified WPS is the official recipe card for the shop floor, but with slightly wider tolerances allowed by the standard based on that test.
Yeah.
Exactly right. Now, the standards also do something really important. They classify all those conditions of the welding variables into two key types:
Which are?
essential variables and non-essential variables.
That sounds like a really critical distinction. What separates them? What makes one essential?
Okay, so essential variables are parameters that if you change them beyond the limits allowed by the standard, that range we just talked about, they're considered to significantly impact the mechanical properties of the weld.
Ah, okay. Change them too much and you might mess up the strength or toughness.
Precisely. If you need to operate outside the allowed range for an essential variable, you've effectively stepped outside the bounds of your proven recipe. You must requalify the WPS, do a new test. They define the limits, the boundaries of your qualification.
Got it. So fiddling too much with an essential variable basically changes the fundamental nature of the weld, and you have to prove all over again that it's still good.
Exactly. Non-essential variables, on the other hand, still need to be listed on the WPS. They're part of the procedure, how you do the weld. But changing them within reason doesn't significantly affect the key mechanical properties.
Okay.
So you can change a non-essential variable without having to do a whole new qualification test. But you would need to update the WPS document itself, write a new revision of the WPS to reflect that change.
Okay, like updating the recipe card for a minor tweak that doesn't really change the final dish's taste or texture, adjusting the salt a bit maybe?
That's a pretty good analogy. The source gives some useful examples of EU essential variables just to make this concrete.
Yeah, let's hear some.
Okay, well, the welding process itself, absolutely essential. There's no range. Qualifying a procedure using, say, stick welding, MMA, gives you zero qualification to use TIG welding instead.
Makes total sense. Completely different techniques, different results.
Right. Heat treatment is another big one. If your procedure test involved post-weld heat treatment, PWHT, to get certain properties, then you are only qualified for production welds that will also get that same heat treatment. You can't just skip that crucial step in production.
Right. Can't skip the baking step if the recipe relied on it for the right consistency.
Exactly. The parent material type being welded is also essential. Often, standards group materials into material group numbers, especially in the EU system.
Grouping similar metals.
Yes, bundling together materials that have similar welding characteristics. The idea is qualifying on one material generally qualifies you for others within the same group. But you usually can't jump between groups because different alloys need different handling, different parameters.
So proving you can weld, say, one type of carbon steel doesn't automatically mean you can weld stainless steel or aluminum using the same procedure.
Definitely not. Other examples. Material thickness. The thickness you test on defines a specific range of thicknesses you're qualified to weld in production. Can't test on thin sheet and then weld thick plate. The type of electrical current, like AC versus DC, and for DC, the polarity, is essential. They affect heat input and weld profile. Preheat temperature, the temperature you heat the parts to before welding, is essential. The minimum preheat used in the test becomes the minimum you must use in production.
And temperature between passes?
Interpass temperature, yes, also essential. The maximum interpass temperature reached during the test becomes the maximum you're allowed to reach between passes in production. Controls the cooling rate.
And heat input. That sounds like a big one, tied to how much energy you're actually putting into the weld per inch.
It is, and it's often tightly controlled, especially when properties like impact toughness, say for low temperatures, or hardness, are critical design requirements.
How controlled?
Well, the source notes that if impact strength is required, your production heat input is typically limited, often to a maximum of maybe 25% above the heat input used in the successful test.
So you can't just pump way more heat in.
Right. And conversely, if controlling hardness is the key issue, the minimum heat input allowed in production might be set at, say, 25% below the test heat input to prevent issues. These ranges are there to make sure those critical properties aren't compromised by using very different heat levels in production versus the test.
Wow, that level of detail is pretty intense. It makes sense, though. So what happens if a welder, maybe accidentally, maybe trying to speed things up, uses conditions outside that qualified range specified on the WPS during a production weld?
Yeah, that's a serious situation. Because that specific weld, made outside the proven parameters, might not actually possess the required properties. It could compromise the structure's safety.
So what do you do?
The source outlines the two main options. Option 1, you could try to perform a new procedure qualification test, deliberately replicating the incorrect conditions that were actually used on the production joint.
Try to prove the mistake was actually okay after the fact.
Sort of. If that test piece, made with the wrong parameters, passes all the NDT and DT requirements, then you might be able to make a case to retroactively accept the production weld. But it's complex, needs careful justification.
Sounds like a bit of a gamble, and maybe not always possible. What's the other option?
Often the more straightforward and arguably safer approach, if it's feasible, completely remove the affected weld, cut it out, grind it out, whatever it takes, prepare the joint properly again, and then re-weld it, this time strictly following the correct qualified WPS.
Okay. Remove the potentially bad weld and just do it right this time, making absolutely sure to follow the proven recipe.
Exactly. That's usually the preferred route. And it's worth noting, while the concept of essential variables is pretty universal between major standards like EU and US ones, the specific ranges allowed for those variables might differ slightly. And application standards say for bridges or pressure vessels can add their own extra essential variables or tighter range requirements on top.
Right, context always matters. Okay, so that's the first pillar, the proven method, the recipe book with its strict rules and defined limits. But, like we said right at the start, you need a skilled maker to follow that recipe consistently.
Absolutely. And that brings us squarely to the second pillar, welder qualification.
Okay.
Because even with a perfectly qualified procedure, the actual integrity of the final weld completely depends on the welder's skill, their ability to execute that procedure reliably, day in, day out, and produce welds that are free from unacceptable defects.
So welder qualification tests are all about demonstrating that personal skill level. Can they actually do the job?
Precisely. They show the welder can manually manipulate the electrode or the torch correctly or control the automated equipment properly to produce specific types of welds in various materials, often in challenging positions.
And just like with procedures, there are specific standards governing welder qualification too.
There are, yes. The main EU standards are BS, EN, ISO 9646 for manual welders, and EN 1418 for operators of welding machines. In the US, it's often ASME Section IX again, and AWS D1.1 or D1.2, similar families of standards.
Okay. Now, the source mentioned a slight difference in how qualification can happen in the U.S. compared to the typical EU approach.
It did, yeah. It's an interesting alternative. While the EU standards generally require a dedicated test piece, welded purely for the purpose of qualification.
The practice piece again.
Right. The U.S. standards, like ASME IX, sometimes allow an alternative route. A welder can potentially be qualified based on the results of NDT performed on their very first production weld.
Really? Qualifying based on a real-world job right off the bat?
Yes. If that initial production weld passes all the required inspections according to the relevant code or standard, they can sometimes gain their qualification based on that successful real-world performance rather than a separate test coupon.
Interesting. So how does the more typical EU welder test usually work then, the dedicated test piece route?
It mirrors the procedure qualification in some ways, but the focus is entirely on the person's ability, their skill. An engineer prepares a WPS specifically for the welder's test piece.
Okay.
The welder then makes that test weld. And critically, a welding inspector observes them during the actual welding.
Watching their technique.
Awesome. Ensuring they're following the WPS correctly, handling the equipment properly.
Checking their adherence to the steps.
Exactly. Again, optional third-party monitoring might be involved.
Yep.
Once the test weld is completed, it undergoes NDT, visual, MT or PT, RT or UT as required. And depending on the material or process, maybe some destructive tests too, often bend tests or macros.
Similar testing, but focused on whether they produced a sound weld following instructions.
Precisely. And if they pass all the tests,
What do they get?
if successful, the welder receives a welder's qualification certificate. This certificate is key. It lists the specific conditions they successfully welded under during their test, the process, material, thickness, position, etc. And based on the rules in the standard, it specifies the range of qualification. This defines the types of welds, materials, thicknesses, and positions they are now officially permitted to perform in actual production welding.
Ah, so this certificate is like their personal license. It says, you've proven you can weld these kinds of things.
That's exactly what it is. And again, if an external body, like a notified body, was involved in witnessing or testing, they might endorse the certificate too, adding another layer of verification.
Okay. So a welder can only make production welds if those welds fall within the specific scope listed on their personal certificate.
Correct. They must work within their qualifying range. And just like with procedures, welder qualification has its own set of essential variables that define the boundaries of that certificate's scope.
Okay, essential variables again. Are these the same essential variables as for the procedures?
Some do overlap, yes, like the welding process, but the definition of an essential variable for welder qualification is slightly different. And importantly, the allowed ranges for welder qualification are often significantly wider than for procedure qualification.
Wider ranges. Why is that?
Because for a welder, an essential variable is something that, if changed beyond the allowed range, would likely require greater skill or a different technique than what they demonstrated in their test weld.
Ah, okay. So the procedure test, WPQR, is about proving the recipe itself produces the right material properties within tight limits. But the welder test is about proving the person has the fundamental skill to handle variations within a broader but still defined scope.
Precisely. It acknowledges welder adaptability to some extent, while still setting limits. The source highlights some key EU welder essential variables, similar to its Table 6.4.
Like what?
Well, the welding process, as mentioned. No range there. You test on TIG, you're qualified for TIG.
Can't suddenly decide to use stick if you only passed a TIG test. Still makes sense.
Right. The type of weld is also essential for welder skill. Qualifying on a standard butt weld in plate usually covers most common joint types, except for potentially trickier ones like pipe branch connections. And significantly, a fillet weld test typically only qualifies the welder for fillet welds.
Okay, because making a fillet is a different skill than a full penetration butt weld.
Exactly. Parent material type is essential, again, often using those material group numbers. But the groupings allowed for welder qualification are often broader than for procedure qualification. It recognizes that a skilled welder can often adapt their technique to a wider range of similar materials, even if the procedure itself might need requalifying for properties.
Okay, slightly more flexibility on material for the person's skill.
Generally, yes.
Yeah.
Filler material type is essential. They need to use a filler within the range they tested with. Material thickness has a qualification range. Often, testing on a certain thickness, say above 12 millimeters, might qualify the welder for a range down to maybe 5 millimeters or so and upwards. The standard specifies these ranges.
And pipe diameter. You said that was tricky for procedures. Is it for welders too?
Very much so. Pipe diameter is a critical essential variable for welder qualification. Welding small diameter pipes requires very different manipulation skills compared to large pipes. So qualifying on a specific small diameter might give you a very restricted range. Qualifying on a larger diameter pipe often qualifies you for a range of larger diameters, maybe down to half the test diameter or so.
Rules to prevent someone used to big pipes trying to weld tiny tubing without proving they can.
Exactly. And maybe one of the most obvious skill-related variables, welding position.
Flat, horizontal, vertical, overhead.
Absolutely. Welding flat on the bench is very different from welding vertically up, or even harder overhead. These positions demand significantly different skills to control the molten weld pool against gravity.
So you qualify for specific positions.
Yes. Qualifying in a more difficult position, like overhead, which might be coated PE and pipe, or a specific inclined pipe position, like HSL 045, often qualifies you for easier positions as well, like flat or horizontal. But testing only in the flat position only qualifies you for flat. It's very position specific.
Okay, so the certificate is this really detailed snapshot of exactly what that welder has proven they can handle: process, material group, thickness, range, positions, joint types.
It is.
But how long is that snapshot valid for? Is it like once you pass, you're qualified forever?
Definitely not.
Yeah.
This is a really, really important point. The source emphasizes the period of validity. It's not indefinite.
Okay, how does that work?
So a welder qualification certificate officially starts on the date the test weld was successfully made and passed.
Simple enough start date.
But here's the critical part for maintaining it. It must be confirmed as valid every 6 months.
Every 6 months. By who?
By a responsible person within the organization, usually someone like a welding supervisor or welding coordinator. This person has to formally confirm that the welder has been actively working within their range of qualification during that 6-month period.
Okay.
If that confirmation doesn't happen, maybe the welder was doing other work or was off, then the certificate becomes invalid.
Wow. So you essentially have to actively use your qualification and have someone vouch for it regularly, or you lose it.
That's the essence of it, yes. It's about ensuring continuous practice and ongoing competence within their qualified scope. Now, the standards do allow for the extension of the initial validity period beyond that first 6 months. And how this extension works should ideally be chosen and noted on the certificate when it's first issued.
Okay, what are the options for extending it, keeping it live?
Well, the simplest, most straightforward option is just retake the qualification test periodically. The standard often specifies retesting every 3 years, for example.
Okay. Prove it again from scratch every few years. Clean slate.
Exactly. Option 2, under certain conditions, allows the certificate to remain valid for a longer initial period, say up to 2 years, without a full retest.
Under what conditions?
Provided the welder works continuously for the same manufacturer or company, and that manufacturer has a certified quality management system related to welding, like ISO 383v42 or ISO 38343.
Ah, okay. So if the company itself has a certified system for managing welding quality, the standards sort of trust that system to provide ongoing oversight of the welder's performance for a bit longer between formal checks or tests.
That's the underlying principle, yes.
Yep.
It recognizes the role of a robust company quality system. Now, beyond these initial validity periods and extensions, the source also describes a specific process to prolong the qualification. This often involves using evidence from production work, and it usually requires assessment by an examiner.
Prolonging, how's that different from the 2-year extension you just mentioned?
It's a specific method, often used near the end of a validity period, like the 2 or 3 year mark, to keep the qualification active past its initial expiry date, based on proof of recent high-quality work.
Okay, using real work as evidence. What kind of evidence?
It requires traceable records, records that clearly link the welder to the specific WPSs they've been using in production. And crucially, it requires supporting evidence from volumetric examination.
Volumetric, meaning RT or UT again, looking inside the welds.
Exactly. RT or UT testing results from at least 2 actual production welds made by that specific welder within the last 6 months before their current qualification expires.
Wow, so they have to show documented proof from their recent real-world jobs that their welds are internally sound, not just visually okay.
Precisely. And those production welds are used as evidence. They must not only pass the standard acceptance criteria for any imperfections, but they also must have been made using essential variables that fall within the scope of the welder's original qualification test.
So the proof has to match what they were originally tested and certified for.
Correct. It's a very specific, evidence-based way to demonstrate their ongoing skill and their successful application of their qualification on actual recent jobs, allowing the certificate to be prolonged, often for another couple of years.
That's a lot of layers, checks and balances. From the initial recipe testing, the WPS qualification.
The WPQR.
Right, the WPQR proof, then defining the essential variables, the qualification ranges, then testing the welder, issuing their certificate with its range, and then this whole system of 6-monthly confirmation and periodic prolongation or retesting to keep it all valid.
It's a comprehensive system, absolutely. And it's all designed fundamentally to minimize risk and ensure quality.
Okay, so let's bring it all the way back. For the listener who isn't, immersed in welding codes every day, why should someone care about all this intricate detail, this system of procedure and welder qualification? What's the real takeaway for them?
Well, you should care because, honestly, it's the unseen guarantee. It's the assurance behind the integrity and safety of so much of the infrastructure, the products, that you rely on, probably without even thinking about it, every single day.
Like what?
Like every bridge you drive over, every tall building you see or work in, every pipeline carrying essential resources like water or natural gas, even things like pressure vessels in industrial plants, the frame of your car, heavy machinery. So many things depend critically on the quality of welded joints.
Right. It's not just luck or chance that they hold together under stress.
Absolutely not. It's this detailed, systematic process. Testing the procedures to make absolutely sure the weld will have the right properties. Testing the welders to confirm they have the skill to consistently execute those procedures properly without defects. That's the backbone.
Okay.
It's the rigorous, documented system that gives engineers, regulators, and ultimately you, the confidence that these critical structures and components are safe and will be reliable throughout their intended service life.
It really sounds like a fundamental, almost invisible layer of safety assurance that's just built into the physical world all around us.
It really is. It ensures that when an engineer designs something, and that design relies on a weld having specific characteristics, strength, toughness, whatever it may be, that weld can actually be produced reliably, consistently, by a qualified person following a proven, tested method.
Okay, so to kind of sum it all up then, we've seen how these qualified welding procedures, the WPSs based on WPQRs, they're like the scientifically proven how-to guides. They ensure you can create welds with the necessary properties.
Consolidated method, yes.
And then qualified welders, they are the skilled craftspeople, the professionals who have proven they can consistently follow those procedures correctly and build sound, reliable joints.
The competent hands to execute the method.
And they absolutely rely on each other. You need both.
You absolutely need both. The best procedure in the world is useless if the welder can't follow it or lacks the skill. And the most skilled welder can't guarantee the right properties if they aren't following a properly qualified procedure for that specific application. One without the other leaves a huge gap for potential, even critical, failure.
Yeah, it really underscores the hidden complexity and the crucial skill that goes into making the things around us safe and robust.
Hmm.
So, considering this level of detail, this whole system just for ensuring good welds, it makes you wonder, doesn't it? What other complex, maybe unseen systems are out there, absolutely essential for ensuring the safety and quality of other products, other parts of the infrastructure we use daily? And what does that reliance on hidden systems tell us about, I don't know, the vital importance of rigorous standards and skilled craftsmanship in a modern world we often just take for granted?
That's a really interesting thought to end on. What else relies on this level of unseen diligence?